Okay, so always remember how the voltmeter and the ammeter are connected, right? So that's like connection to the wire. But in the circuits, you need to remember ammeter is always connected in series, and then the voltmeter must be connected in parallel. Okay, so it will be actually seen inside our worksheet. Let me just close that. Okay, now, so if we look at our worksheet 20, some of you tried to do this, some of you didn't do lah. Okay. But I think it's quite manageable, right? Not that difficult. Today's lesson could be even quite short also. But I'll be asking you certain questions along the way, just to check your understanding. Okay, can see this, everyone? Right? Give me okay, good. At least give me some indication. Okay, now, electrolysis makes use of the what kind of effect? If we talk about effects of electricity, okay, let me quickly run through review. There are a few of them. In fact, you can find it inside your book. Okay. Okay, there is chemical effect, right? Like electrolysis, like electroplating. Then there's also heating effect. Okay, so the electric iron, electric kettle, okay, electric heater, hair dryer also. Okay, this is where the electricity is converted to the heat. So there's a heating effect of electricity in these examples. Lighting effect of electric current. So talk about electric bulbs. Okay, fluorescent lamps. So when electric current is passed through a conductor, like the filament of the light bulb, okay, it's going to become very hot. It will glow so brightly that light is emitted. And then electric current passed through a wire, then it can behave like a magnet. So we learn about this, right? Magnetic effect. So you have the electromagnet, and that is created using electric current. So once we disconnect the electric current, no more current flows, right? The magnetic effect of the electromagnet is lost. Okay. So in this case, quite clearly, answer is A. All right. Look at the answers here. Okay, good. All of you got this correct. Next, question 2. Sally sets up an electrical circuit as shown here. So she wants to find out how much current is flowing through the circuit. So if you want, if you want to actually find out how much current is flowing, what do? What can you actually use? Okay. I think we all remember this part here, right? Okay, we use the ammeter, okay, to measure current flowing in the circuit. And then voltmeter is to find out the potential difference, all right, across a component. Nicole, are you okay, Nicole? Yeah, you sign in 2 gadgets. What happened? One not working, huh? Your internet. Okay. Okay. So which is better for you? Which one is better for you? You play by ear lah, huh? So if let's say sometimes it's the first gadget, then you have to focus on the second one, vice versa. Is it okay? Then anytime your connection is not good, right? You need to disconnect, no problem. Just disconnect and reconnect again. I will just let you in. Now, if you look at the textbook, okay, I go back, this particular page in your textbook. To be page 18. And then you have 19 as well, 20. Okay, so you have effects of electricity on these pages, just for your reference. So let's say you want to read more about it, you can go to your book. Okay, then this is ammeter. Label it yourself and label the voltmeter also. What is B? Okay, what do you think is this component? What's the name of this component? Type it into the chat. Ah, nobody's typing. What happened? What is the name of this component B? Yes, correct, Jocelyn. That is called the resistor. Now, if you were to refer to your textbook also, okay, page 13, you will have that symbol there. Don't know whether you can see my book. Okay, yeah, you have the symbol there. Okay, you have the resistor and then the variable resistor also on this page. Then you have the light bulb. Where did they put the light bulb? The light bulb you already know, right? Ah, okay, sorry, page 6. So if you refer to your textbook, that will be helpful. Okay, thank you, Jocelyn. Yeah. So in order to measure current, we will connect the ammeter. Okay, ammeter. Ammeter measures current. You all got it wrong, is it? Oh, some of you put B, some of you put C. Answer is A. Okay, ammeter measures current. Voltmeter measures potential difference. Okay, resistor. What is the function of the resistor? Okay, resistor actually controls amount of current that is flowing through the circuit, isn't it? Remember, we talked about this. Okay, last lesson we did talk about this. We even talked about the rheostat. Right? This is the variable resistor. And usually when you see the variable resistor, there's an arrow going across the rectangle. Okay, this is the variable resistor. We learned about this last week. Can you recall? Can you recall? Give me a thumbs up. Must respond because you're the one to turn on camera, then you have to respond. Okay. So I know that you're in the lesson. Nazil, are you there, Nazil? You need to respond. Okay, why thumbs down, Jocelyn? Don't remember. Oh, you don't remember about the rheostat? Is that right, Jocelyn? You still recall that video we watched about rheostat? Or you don't? Oh, it was laggy. Let me see. You give me a short while, I will find for you. Let's see whether it's still laggy today. If it's still laggy, then I have no choice that I'll send to you. How? Okay or not? Do you understand better now, Jocelyn? This is actually a rheostat. It's very big. The actual resistor, okay, that you see in normal daily life, they are extremely tiny. Can or not, Jocelyn? Can you understand? Is there any question you want to ask me? Javier can understand now? So it must be because it was laggy, right? That's why you can't understand so well. Okay, no problem. At least now we know. Let's see if I can send this to you. Okay. Never mind. I send it to you another time. Too big. Okay, great. So let's continue with the worksheet. Now, Nazil, actually, we are looking at this topic on electricity, just in case you're wondering what we're doing. Okay, but I saw that you did your work as well. So Nazil, can you just share with me very quickly, are you on this topic in school? You can type into the chat, Nazil. Javier is not, huh? Okay, Sherman leh? And Nicole, maybe tell me also. Jocelyn as well, type into, okay, Sherman, you're doing it, okay. Not yet, huh, Jocelyn? Nicole is doing this topic. You're not sure. How come you're not sure, Nazil? You're making me worried. You don't know which topic teacher has gone through. Later I talk to you, okay? After the lesson, you share with me more about yourself and the subject. Okay, Nazil? Okay, so let's continue. Right. So if you look at this question again, okay, this shows a fixed resistor. If I were to write down, my pen is not working. Okay, this is a fixed resistor. That means it is not like the rheostat, right? That can actually allow current to flow by a lot or very little. You do not control it that way. Okay, a fixed resistor means you put it in, right? The light bulb will just continue to light up in the same brightness throughout. Okay, you want to have a dimmer kind of setting, you will need a rheostat. Okay, so that you can control how much current you want, okay, to be flowing in the circuit. If you want to have very bright lights, then you are going to have low resistance. Okay, but if you want to have dim lights up, not so bright, okay, you're going to create some romantic effect, then you will have to use or you have to adjust to high resistance so that lesser current flows through. Okay? So maybe if I were to write down high resistance, okay, low current flow, right? So the bulb will be dim. Then if it is low resistance, higher current will be flowing through the circuit and the bulb will be very, very bright. Yeah, so maybe you want to jot down something like this. For the rheostat, this is how it works. Adjusting the tap. Okay, you can increase resistance or you decrease the resistance and that alters the current flowing. Sometimes we call it lamp, sometimes we call it bulb. Any question here? Can I go on? Can go on? You give me thumbs up. If you're still copying, it's okay. All right. Okay, great. Sherman, okay, Sherman? Now, which of the following here will have at least one bulb still lit? Okay, at least one bulb still lit, even if bulb X were to blow. Okay, so now I'm going to indicate like this. So you see, current cannot actually flow because there is an open circuit here. Okay, so current can't flow. This two will not light up also. Okay, so if I'm looking at B, all right, so I have Y and Z lit. Because current still can flow through the circuit. Yeah. So this two still lights up. So let's look at C now. Okay, so if for C, X actually blows, okay, there is no way current can flow, all right, because this is the open circuit. Doesn't light up. For this one, okay, Same thing,